Hello, my name is Coach Holmes and welcome to our first lesson on geometry. And today we're actually going to be talking about addition property. Now, we are going to do a little bit of review on algebra, and the reason why is because in geometry there's a little bit of algebra involved. But majority of it is going to be just solving equations, okay? You just got to be able to set up the equation, not only just set that up, but also be able to solve it, okay? So there is going to be some algebra involved with geometric principles and property, but we'll dig into that a little bit more in a couple of weeks. But for right now, I want to make sure that you guys get a good understanding of how to do algebra, mostly by solving equations. That's our main focus on today. We're going to be focusing on solving equations. But today, we're going to make sure we understand how to use addition property in order to solve the equation. Okay? So, now some of y'all may be wondering, well, what is addition property? Well, in your notes, we're going to write those definitions, which, by the way, anytime you need to pause this video to write down the definition, you're more than welcome to do so. This is for your benefit. So if you need me to slow down, you can definitely pause it, write down the notes, which, by the way, your notes is a link to Canvas under the title Notes in your announcements. So you can definitely copy this down and you should be able to follow along with us. Now, the definition for addition property is add the same number to both sides of an equation where they remain equal. Now, some of y'all may be wondering, well, what does that exactly mean? Well, here's a physical demonstration of what it really means. So imagine if you actually lift weights, okay? If you lift a bar, okay? So if I'm lifting a bar, I add 10 pounds on the right side. It wouldn't make sense if I just add 10 pounds on the right side and I don't add any weight on the left side. And the reason why is because the weight will start feeling weird, it'll start feeling awkward, and I can't get much out of it. So if I add 10 pounds on the right side, I'm gonna add 10 pounds on the left side. So that way I'll be able to lift the bar up evenly, okay? Now, but it's also important that you do it on the same amount of weight. Not just the fact that you add weight on both sides, but the same amount of weight. Because even if I add 10 pounds on one side and 5 pounds on the other, it's still just as counterproductive. So I want to make sure if I add 10 pounds on one side, I add 10 pounds on the other. That's the basic definition of addition property. Now, we will talk about subtracting property, but the principle is still the same thing. If I take off 5 pounds on one side, I still want to take off 5 pounds on the other side. So even with a subtraction property, it works out the same way, except this time we're taking weight off. Okay? So let's look at a couple of examples, and these examples are in your notes. So here's some samples by adding, okay? So if I want to add into the equation in order to solve it. So I have the equation y minus 8 equals -3. Now, I gotta get the y by itself. That's the real goal of algebra. Be able to get the unknown variable by itself so you can figure out or identify the value of that variable. But this variable is subtracting from 8. Okay, so I gotta do the inverse. I gotta do the inverse of that operation. And basically what inverse means, it's just doing the opposite operation. So the opposite of subtracting would be adding. So instead of subtracting 8, I want to add 8. Now, just so that way we get a good idea of which side is which, I'm going to draw a line through the equal sign. So I'm adding weight on the left side, okay? Adding weight on the left side. I'm adding 8. So if I'm adding 8 on this left side, I gotta add 8 to the right side. So initially, not only am I doing negative 8 plus 8, I'm doing negative 3 plus 8. Negative 8 plus 8, they cancel each other out, or eventually equals a 0. Now, since they cancel out, the only thing I have left is the y. So I'm going to bring that down. Excuse my writing. Now, so I'm having y on the left side. Now I'm going to do negative 3 plus 8. So if I add negative 3 to 8, that means what I end up getting is the value of 5. So you add 3 to the negative 3 to get 0, and you have 5 remaining. So I'm going to get a value of y equals positive 5. So my y value is going to be positive 5. Now, let's look at a second example. A minus 4 equals 5. So again, I got to do the inverse of this operation, which is, now, the operation is subtracting. And the inverse, or the opposite of subtracting, again, is adding. So I want to add 4 on the left side. So if I add 4 on the left side, I got to add 4 to the right side. Negative 4 plus 4 cancels out. I get A equals 5 plus 4, which gives me 9. So the value of A is equal to 9. Now, those are just samples of adding, okay? Anytime you have a negative in front of the constant or just the number itself, you gotta make sure you do the inverse of it. So since it's subtracting, I'm gonna add to it. Now, here's some examples when it comes to subtracting the constant, okay? So instead of adding both sides, I'm gonna subtract, but it still works out the same way. Now, negative 6 equals y plus 7. Now, it is a little bit backwards, okay? Now the variable is on the right side, but even if it's on that side, it's still going to work out the same way. But let me show you what happens. Since I got y plus 7, since I'm adding 7 here, I got to subtract 7 from both sides. So when I'm subtracting 7 from both sides, this cancels out. So I have y on the right side. Negative 6 minus 6. Since I have two negatives here, they're basically adding each other up, making a bigger negative. So negative 6 minus 7 gives me negative 13. Now, this is technically my answer, but you should be able to write it out like this, where it's y equals negative 17. Okay? Made a mistake here. This should be a positive 5, not a negative 5. My mistake. Okay? Now, same idea though. Okay? 10 equals 5 plus 8. I still got to be able to solve for A. But remember, now this is also a little bit backwards too, because now the constant's up in front. So it's like, well, should we subtract A? No, we don't need to. and there's no need for it, plus it makes it a little bit harder. But I can still subtract this 5, because I know this 5 is positive. I'm going to subtract it from both sides. So if I draw the line, just so that way you guys know which side I'm really subtracting from, I'm subtracting 5 from the right side. So that means I subtract 5 from the left side. So 10 minus 5, that's going to give me a positive 5, equals A. Let me get rid of this part right here, just so that way, there we go. That way it doesn't look like it's not equals 2. There we go. But again, yes, it's technically, yes, it's the answer, but you should write it out like so, where it says A equals 5. And that will give me my answer. So again, just to recap in your summary, you can write this in your own words, but the idea behind this is that you've got to do the inverse operation for each one. The inverse for subtraction is going to be addition. So if I'm subtracting, I gotta add both sides. But if the original problem is adding, I gotta subtract both sides. Okay? So just be aware that the opposite of addition is subtraction, opposite of subtraction is addition. As long as you do the opposite of the equation, you will be able to solve the equation itself. But you also got to remember though, it's got to be the same amount. I can't just say minus 5 on one side and minus 7 on the other because I want to. That will mess up the entire equation. So if I'm doing negative 5 on the right side, I'm doing negative 5 on the left side. So just be aware, what you do on one side, you do to the other by the same amount. Thank you.